Thank you, Vanessa, for that introduction. And thank you for your time today. I'm really excited to be here. And I wanted to talk to you about not only our company, but the fact that firstly, you don't need to buy a new gas turbine to decarbonize your existing, to decarbonize 100%. I'm going to offer you an opportunity to upgrade your installed fleet of gas turbines, can-annular combustion systems, with one of two platforms, simple retrofits that will allow you to get on that pathway, that journey towards 100%, and in some ways, extremely dramatic. I also note through my count that there are 8 different colors of hydrogen, not including refinery off-gas, which is a bit of a mix. But I will talk a little bit about the fact that from our standpoint, we're relatively colorblind when it comes to hydrogen. First thing I wanted to do was explain the fact that we are PSM and Thomason, our sister company. We are an aftermarket and an independent service provider. That is, those gas turbines by the major OEMs that you currently have, or the companies that operate and generate power, we are able to service those gas turbines. And the vast majority of these units, the thousands of gas turbines that are currently installed today, we are able to service from everything from advanced combustion drop-in retrofits to the delivery of brand new components for the flow path, the repair, the field service, and that can all be wrapped up into long-term service agreements, but very flexible depending on what your needs are. In terms of footprint, I think what I wanted to mention here was that we have 2 technology competence centers. One is in Jupiter, Florida, where PSM is located. The other is in Rheden, Netherlands, where our sister company, Thomason, is currently operating. And we share the same common R&D, the same technology and product solution DNA, and just executed out of different organizations throughout the world. Now, Torsten brought this up a little bit relative to the hydrogen supply chain. And I will tell you this, I do not view the barrier being in the gas turbine. There is simply a matter of time before we're able to get to 100% hydrogen dry retrofit solution for installed base gas turbines. The issue is clearly on the upstream. I think we've got a good handle on the renewable side, or from a green hydrogen standpoint, or green standpoint, the renewable aspects, that's coming along very nicely, but certainly when it comes to the amount of hydrogen one needs to make an impactful reduction in CO2, the challenge is somewhere in the middle. And that is the cost and scale and installation capacity for things such as electrolyzers, even steam methane reformation if one is talking about carbon capture and sequestration, and then storage. Storage can be liquefied, it can be compressed, it can be geologic storage under compression, all of which will be able to support the decarbonization of gas turbines. The other thing I want you to take away from this is that think of hydrogen not so much as a fuel, but think of it as the ability to do energy storage on a grid scale basis for the power generation industry. It's different than batteries. Batteries certainly serve a purpose in short duration modulation of, say, voltage or quick micro responsing. In terms of hydrogen, it's a matter of huge amounts of energy that can be stored, released to be used as a fuel for the gas turbine, and completely to the point, decarbonize the gas turbine. So think about this, with 100% hydrogen, the gas turbine becomes just a turbine, just another energy conversion device that can be fully implemented and compatible and supportive of a totally decarbonized power grid. Now, real quickly about Hanwha. Hanwha is our current owner. They are a Korean conglomerate based in Seoul. They have a very nice strategy in terms of how they want to participate in the low carbon economy. The first is they acquired our companies, Thomason and PSM, to be able to handle and develop hydrogen technology for combustors, for retrofits, and also use that to begin to decarbonize the installed gas fleet in Korea. The other area where Hanwha is also very extensively placed is in the renewable side. Hanwha is one of the leaders in terms of solar farm development, particularly in the United States, but also globally recognized for solar panel manufacturing through their company QCell. And the area where Hanwha is also looking to develop, but we are also working with partners, is on that gap in the middle. Who, from an electrolyzer standpoint, compression standpoint, integrative standpoint, do we work with, and we are currently working with, to bring this hydrogen ecosystem to your gas turbine. The other thing I wanted to mention is it's not just a retrofit of the combustor, although in its essence that's what it is. But when we talk about retrofitting the gas turbine for hydrogen, our delivery scope is also the modification to the existing fuel skid, as well as all the controls requirements to do that. So we try to make it as simple as possible for the power plant operator, who may not recognize how challenging it is or where they're going to get the hydrogen, but make it as simple as possible to just bring it to the power plant yard, and then we handle it from there and commission the system from there. I don't need to go into necessarily the challenges with climate change and decarbonization. Safe to say, though, that I do see the opportunity for decarbonizing with hydrogen accelerating. Once where everyone was first placing their 2030 and 2050 objectives, 2030 now becomes 2020, now becomes 2023, 2024, with real tangible modifications to existing gas turbines. The thing that really makes gas turbines just so compatible with the existing power grid is the responsiveness. Here you see the variability with common power plants, renewables, but you're also seeing the issues with power plant, power pricing, which is being challenged with natural gas. So this is an opportune time to consider alternatives for fueling of gas turbines. Not just natural gas, but now with hydrogen, because the mechanisms for subsidies and also premium for carbon sequestration or carbon reduction will be there. So the business case is beginning to form. It's providing some solidity to those of you who are looking to make decisions within the next few years. So the gas turbine becomes just a tremendous, flexible, responsive device, and hydrogen becomes a measure of energy storage to be released into the power grid for those gas turbines to use. Very important when the wind stops blowing and it's very cloudy days. I think we've had issues where the wind stopped in the North Sea for a few days and the power prices began to spike. Well, just now imagine you're in a situation where you don't have to worry about that. Just use the existing gas turbines. You'll get paid for decarbonizing, and it will be a useful asset for as long as you need it, whether it's 5 years, 10 years, or 20 years. You all have different timelines between either buying new equipment or retiring it. Well, a retrofit solution gives you that flexibility to meet your business case. Now, one of our core competencies is combustion retrofits. We've been doing it for over 20 years now. We've been doing it on B and E class, let's call them relatively mature gas turbines, as well as F class, which I would argue today, since they've been out there for almost 30 years or so, they're also mature. But we've installed over 100 retrofits. And this isn't just a replace in kind from an OEM solution. It can be an old diffusion combustion technology where not only are we replacing the combustors, but we're implementing a new control system, the fuel skid, fuel delivery piping. It can be casings, it can be spark plugs, flame detectors. The entire scope is something that we do, and we have two platforms. One's called the LEC platform, which is more for the smaller, let's call it below 120 megawatt solutions. And then we have our flame sheet technology, which I'll introduce to you today, which is our universal platform for all can-annular combustion gas turbines that are out there today. One platform, geometrically scalable, up to 100% hydrogen, but maintaining all of the characteristics you require in your gas turbine, such as flexibility, turn down, very low emissions, because it has the ability to consume anywhere between 100% natural gas and 100% hydrogen. Now I wanted to just speak to an example of an existing retrofitted plant today with our technology. This is in the Netherlands. And one of the first, and say, quick hit successes is with refinery off-gas. Typically that's going to be with a high amount of hydrogen. Well, that's the case here. This is a 3x9E cogen power plant that's not only supplying power to the grid, but right next door, this is in Terneuzen, Netherlands, is a chemical plant which requires the steam from this cogeneration plant for chemical processing. In turn, they're giving hydrogen back to the gas turbine to offset fuel costs. They're owned by the same chemical plant, or chemical company, and also decarbonizing the gas turbine at the same time. The scope, again, is relatively straightforward. The modification to the fuel skid, the fire protections, explosion controls, the leak detection, the ventilation, very straightforward, well-known implementation of this technology. A slight adaptation to the control system with a product we call Combustion Auto Tune, which will be able to instantaneously tell the variation between hydrogen and natural gas in your fuel stream. So don't think of it as what is currently being used, gas chromatographs, which are relatively slow. We want to be able to, for you to have any sort of instantaneous change in your hydrogen fuel delivery from 0 up to the amount that the combustion would be able to take, and be able to modulate the fuel splits in that combustor to allow you to operate safely, allow you to maintain your emissions, allow you to keep the combustion pulsations under control. In this particular case, we currently allow the unit to run up to 25% by hydrogen by volume. This is at their request. We tested it to 35% without a problem, with sub 6 ppm NOx emissions across the entire operating load range. We don't view NOx as a real big barrier here, and we do not expect, and we will not have water injection as a means to lower the NOx. And it won't be in the SCR, it'll be directly and organically from the combustor. This is a cross-section of the 7F, but not only is it combustion technology, it's also the fact that over the past 20 years, under these 4 owners, and Ansaldo was our previous owner, we've been able to develop our own replacement components and using our developed technology that brings something different than you would expect or you would naturally get from an OEM. So we went after the weakest link, and as these gas turbines now have moved from a half-life of, say, 15 years to a half-life of 30 years, you're always looking for that next weakest link, and you're always looking for something to be able to keep those assets running profitably. And that's what we've done, not only from the flow path, but also being able to deliver our own discs, our own compressor wheels, and something we're really proud of in 2022, we'll be delivering our first nickel-based superalloy stage 1 turbine rotor for a 7F gas turbine. So again, of our own design, recognizing what the challenges and the issues were in the OEM solution today. Now getting to the combustor itself, the flame sheet combustor, I call it multi-OEM, and I think I'm understating it in that respect when I talk about it in a second. But it's very fuel flexible, it's dry, there's no diluents here, it's dual fuel capable. So in the instance where you may not have natural gas in your power, the power plant or your local regulatory jurisdiction requires you to have liquid as a backup, this also has a liquid fuel system as well. So when you're curtailed with natural gas and or hydrogen, you can run for a number of hours, or as long as as much fuel oil as you have at the power plant, you can run it in that way. But again, look at the NOx emissions here for natural gas. I'll talk a little bit about it with hydrogen, but this is the platform. First developed and currently implemented for the tremendous incremental step change in turn down, which is a very highly valued in certain markets, and then with the low emissions, as well as from a life cycle standpoint, going up to 4 years of continuous operation without taking an inspection. We also use DLR, the German aerospace facility in Cologne, Germany, just as my colleague from Ensaldo, they do their testing there. One of the things you don't want to do is when you're doing combustion, you don't want to burn up and use your customer's gas turbine as a test vehicle. You want to be able to do all the destruction to push those designs in a controlled environment with the types of fuels at engine condition. And this is where we have our own test rig, which you can see on the top left, the top right and the bottom right, where we fully test this combustion platform, including hydrogen. The other element I wanted to talk about is combustion auto-tune. This is a really nice product. If you think of a field of wheat, and typically when a farmer harvests it, there's always extra wheat there that's left over. Whether it's in the corner of the field, it's just too hard to get, too difficult to get with the current technology. That's what auto-tune does for you. It allows you to hot rod your gas turbine and find those areas of wheat. In this case, this is additional profit. And operate safely. It allows you to, in a controlled way, accelerate, modify your startups, and then it can also extend your operational range as well. We have this system in over 100 gas turbines. Today, we're selling about 10 or 15 of these per year, and it really is part of the hydrogen retrofit and part of our combustion implementation, but a simple addition to the existing control system. I am not going to force any power plant operator to change their gas turbine controller. It is not a requirement unless you have model-based control. And if you have it, you know it, and I feel sorry for you. But for those 99% that don't, we can operate on that native control system, whether it's from GE, Siemens, or Mitsubishi. Experience on this flame sheet platform. We have 9 of these operating today. One of them with hydrogen, up to 5% hydrogen, but it's refinery off gas, and that's all that the hydrogen delivery system was allowed to deliver because it was delivering the hydrogen for an OEM solution, which could only take up to 5%. But this system is very modular. It drops right in. It can be retrofitted in the same inspection interval as a hot gas path, so in a matter of a couple of weeks when you're taking routine maintenance. And our experience to date has been just superlative. The hardware comes out looking excellent. In many cases, the operator wants to put it back in because it looks relatively unscathed, recognizing you have combustion inside the system as well. The one thing I wanted to mention here, if you look at these 6 different types of gas turbines from 3 different OEMs. What you're looking at is the same combustion system. It's almost universal, and in this particular case, it's universal and it's the same geometry. So imagine if you had some type of portfolio of this and you wanted to reduce your inventory, and you wanted to have excellent flexibility, turn down, lower emissions, hydrogen capability. You're starting that journey where everyone is being asked to do it today and do it now, but it'll be a couple of years to get there. But future-proof your asset and repurpose it is what you're doing. And imagine only being able to do that with one platform, one set, or say minimizing inventory across these various OEM platforms. A very powerful solution. We're finding customers are beginning to respond very excitedly about this because not only in many cases here in Europe with 9Es or 9Fs or 701Fs, they see that this is a way to reduce their operating costs, which is another key thing we're trying to do. Now, some really important, exciting announcements this year. We are going to be putting in the flame sheet combustor into a 7F gas turbine for JERA in the United States. This is a power plant that is sitting aside a petrochemical plant, a Phillips 66 petrochemical plant. They will be providing JERA, the refinery off gas. It's not just hydrogen. It'll be up to 40% hydrogen, but it will also have ethane, ethane, propanes. Okay, so we are developing today the fuel delivery system for the refinery off gas. We'll be implementing a backup liquid fuel system, and we'll be guaranteeing below 9 ppm NOx emissions across the load range, across and up to 40% hydrogen. And this will be done by the end of next year, and it will allow JERA to begin to achieve their decarbonization strategy, where they'll be able to reduce this particular power plant, their CO2 signature, by 10%. That's quite a bit, since this is operating year-round, and this gas turbine is generating about 90 metric tons of CO2 per hour. So very impactful for them. It's a real win-win for the operators there. And now, speaking about the modularity or the universality of this flame sheet combustor, we will also, with our parent company, be implementing this flame sheet combustor into a 7E gas turbine by the end of 2023. This will also be beside a refinery off gas. The issue is, where do you get your hydrogen? The quick hits and the easy hits today for those in the supporting oil and gas are with refinery off gas. And in this particular case, they'll be able to deliver up to 50% hydrogen. So the question then becomes, how far can this platform go? And I want to stress that we're talking about dry. We're talking about retrofits. We're talking about a delivery of a system that's part of a larger hydrogen ecosystem. Today, in an F-class combustor, the flame sheet platform can operate up to 60% hydrogen by volume. The 40% is just something that was limited in our previous example with JERA, that which is coming from the refinery process. Where we see our technology roadmap taking us today, there's only so much we can do with our LEC platform. But that's okay. The objective isn't to get to 100% necessarily all the time. The objective is to put the right solution into the asset that you may have. But we do see, and we are working on our roadmap, which will be 100% hydrogen capable well before 2030. So when I told you that I don't view the technology required to get to 100%, that being the limitation of the gas turbine, it's really not. The technology is there, it's available. We want to put you and the power plant operators on that pathway to decarbonization. So why do I feel so confident? Well, we do the testing in DLR. We have a large consortium of collaborative partners here based not only in Netherlands but in the EU. We're taking the universality of this flame sheet and scaling it down to where we can test it on a microturbine, a 2 megawatt microturbine made by Opera Turbine out of Hengelo, Netherlands, and do the testing on that and prove to ourselves that we can geometrically scale this flame sheet, not just have a universal one platform, but if you're looking at other gas turbines like frame 5s or 6Bs, or in this particular case, canannular microturbines, you can do it. And what was really exciting is within this year, we've proven to ourselves that we can achieve from 0 to 100% hydrogen in this smaller flame sheet combustor with just about single digits. Below 10 is not a little higher than 9, but lower than 10. But that's at the operating temperature that you would even have, or should I say, the flame temperature that you would have for the gas turbine as well. So, I mean, NOx is an exponential function of flame temperature. So we're talking about the same type of energy required to go into the gas turbine, and we're doing it at DLR. So that's a bit of my wrap up. You can see I'm a little bit excited about it, simply because everybody's clamoring for solutions today. Most people aren't in the market for new gas turbines. They simply want to use the assets they currently have. We see the supply chain and where we can help in the supply chain, but we partner with manufacturers for electrolyzers, for compression, for storage, and we can bring that whole solution if we want to. We're very excited to be a first mover in the commercial market. We only see more of it coming and accelerating. Just as everyone talked negatively about renewables 20, 25 years ago that the turbines looked ugly. They were very expensive. They impacted migratory routes. I didn't want to see them from my backyard. It's the same discussions with hydrogen today, the fact that it's costly. All those barriers are coming down today. We view the gas turbine as the ultimate flexible and compatible energy conversion device for a volatile, renewable dominated grid. Hanwha is working aggressively across the hydrogen change, and think about this. We want to help you renew, repurpose, repower the installed base gas turbines. There's thousands of them out there. Let's just provide the technology to support it today. So that's my speech. Thank you very much.